Okay, we are asked to show that we given this recurrence relation, we are asked to show that this equals to this. So we know that un square we do not want at the end result. There's no un square here. There's also nothing like un minus 2 here. So we have to change to un minus 2 and un in terms of un minus 1. So what is un in terms of un minus 1 is just given this. So I just replace this thing with this thing. Right, so we have 0.5 un minus 1 plus 1 square. Okay, then here I have minus un minus 1, and un minus 2. What is un minus 2 in terms of un minus 1? So let's see from here, because this thing implies that un minus 1 equals to un minus 1 equals to un minus 1. Correct? Un minus 1 times 2. So un minus 1 multiplied by 2. Why am I doing this? I'm doing this because I know that I want to find un minus 2. And un minus 2 in terms of un minus 1. Correct? So therefore I'm trying to change it. From here I know that if I change this to un minus 2, then this one would be one more than this one. So this one will be un minus 1 times 2. Because half when I multiply it becomes multiplied by 2. Right. So if it's not clear, you just think of this as this you bring over become minus 1 plus. Correct? So un minus 1 is this thing. Then half you multiply over, give you the 2. Correct? Yeah. So I'm going to bring it back. Okay. Now, since we have this, then I replace this with this. This is un minus 2. This is un minus 2. So I replace this part with this. So I have un minus 1 times 2. Correct? And I'm trying to show that this is equals to, so this is equals to this. I want to show that it's equals to this. So what do? So I square of 0.5 is 0.25 un minus 1 plus 2 times 0.5 times 1 is just 2 times 0.5 is 1, 1 times 1 is 1, so I get un minus 1 here plus 1. This is just a quadratic expansion, a square plus 2ab plus b square. Then the next thing is minus un minus 1 square, because this one multiply in, right? Oops, there's a 2 there, so might as well I do it with at one go. So the 2 multiply to this as well. 2 multiply to this, then multiply to this, I get this term. Now 2 multiply to minus 1, correct? Then multiply to this. So minus minus become positive. Alright, then 2 multiplied to 1 is 2, 2 then multiply to un minus 1, I get 2 un minus 1. I should only have 2 terms. Then these 2 terms. If you can't do it, then I explain it slowly and you see. First term should be minus, second term should be plus. Okay, can. So then we have this, or we combine all the un minus 1, 2 un minus 1 plus 1 un minus 1 is 3 un minus 1. Then 3, I think I did something wrong here, did I? I didn't get the, no, yeah, I think I'm correct. Right, un minus 1 2 plus 1 3. Then where comes my 0.25? Oh, this one when I expanded I forgot the square here. Okay, the a square, so the whole thing must be square plus 2ab plus b square, right? So I missed out the square here. So now I have 2 plus 1 3. So I have 3 un minus 1. I got this term. Right, plus 1, I got this term here, and this term I will have minus 2 minus 2.25. This is un minus 1 square. This is also un minus 1 square. So 0.25 minus 2, I get minus 1.75 un minus 1 square. So that's it. I managed to prove. So the next part of the question, it tells us that it asks us to consider graph of an appropriate quadratic function. Quadratic function to show that if um minus 1 is greater than what? Greater than, let me see, greater than L. I don't know where the L comes from. Oh, but okay, greater than L is the value that they converge you to. So let me find L first. Right. Then un square smaller than minus 1, minus 2. Right. So in the question, the L is just from the recurrence relation, L equals to half L plus 1. So I have, this implies that I have L equals to 2. 2 times half is 1, 1 plus 1, 2, 2, yes, correct. So L is 2. So in other words, when show that if um minus 1 greater than 2, then this one. But we know that we need to make use of the earlier result, because this part, we can see it here, don't we? Okay, we can see it here. So what is this one? So this is equals to un square minus minus 1 minus 2, and this is this part. So I want to bring this over and bring this part over, so that, and then bring all these terms over, so that I get this a positive. So first thing, I bring this over, I get un minus 1 minus 2, and equals to, this one will be un square, correct? Un square this would be, oops, so I will still have a un square, and that's the issue, right? Oh yeah, no, that's not what it means. That means this one we should rearrange. Un square minus minus 1 minus 2. This one, we want to show that this is smaller than 0. Right, but we also know that, okay, this part is exactly this thing. Minus 1 square plus 3 minus 1 plus 1. Correct? We want to show this. So what graph could we draw to show this? Now this part, this graph, then obviously let's see, we will draw the graph of where our x-axis is minus 1, and this is actually the quadratic equation. From here I know that my y-intercept of this quadratic equation must be 1. Then where would it intersect the x-axis? So I solve for this. This term is actually minus 1 and 3/4, which is minus 7 over 4. So if I solve for this equation, my x, the solution for, let's say I want to find the solution for this, so that I can find the x-intercept. The x-intercepts are minus b, means minus 3 plus minus square root b square, which is 3 square, minus 4 times 1 times minus 7 over 4. Okay, because minus 1 and 3/4 is just minus 7 over 4 over 2a. That means 2 times minus 7 over 4. which we get minus 7 over 2. Okay? So what do we get here? 9, 4 and 4 will cancel away. This will become a plus. So 9 plus 7, 16. 9 plus 7, 16. 16 square root will become 4. 4 minus 3 will be 1. One of them, answer on top is this. The other one is minus 4 minus 3 will be minus 7. Correct? Minus 7 over 2. And this one is just minus 2 over 7 for this thing. And minus minus will become a plus. So we'll get 2. Okay? I'm not just to be, you can check my calculation. I may make a mistake, I do not know. So this one minus 2 over 7 and this one is 2. And where is the maximum point? Actually we can easily find from this. We just add this to this and divided by 2. So minus 2 over 7 plus 2 and divided by 2. Then we'll get the x coordinate of the midpoint. And that would mean 14 minus 2 is 12. Okay, just solve this term. So I get 1 minus 1 over 7. So I should get 6 over 7. So 6 over 7 somewhere here. And if I substitute 6 over 7 into this equation, I should get a corresponding y value, but I'm not going to concern myself so much with the graph sketching right now, right? The maximum point right now, right? We know that it passes through this point. That's good enough, right? Okay. And yep. So what is my so we want the when un minus 1 is greater than 2, that means this part. At this part, my un minus, this is what is this graph? It means this thing, this graph is actually this equation. I mean, this equation is this equation, alright? This graph that I'm drawing is this 3 equation. So especially this equation. So I'll label this graph as y equals to un square minus um minus 1 um minus 2, isn't it? Because we are drawing this graph and this graph is equals to this graph. And we want, since when un minus 1 greater than 2, that means we are looking at this part of the graph. This graph is smaller than 0, negative. Therefore we have proved graphically that this is indeed smaller than 0. So that's it for this question.